So welcome back, Mike. Welcome back. We have our first talk this morning entitled "The Ops in MLOps" to be given by Mike Berg, the Vice President of Technology at AltaML. A little bit of bio about Mike is Mike is a technology leader with a track record of delivering business impact and driving technical innovation. He's currently Vice President Tech at AltaML, which is one of Canada's largest applied machine learning and AI companies. It's focused on advancing our technology vision at scale. So for the next 30 minutes, Mike, you have our attention. Thank you.
Thanks so much, and thanks everybody for joining me. As mentioned, I'm Mike, the VP of Tech at AltaML. We're an applied AI company, a machine learning company, and I spend a lot of my day thinking about the environments that our ML engineers use to work their magic. And I want to talk to you a little bit about that today. So the problem with, there's a lot of talk in the ML ops space about new and upcoming technologies like feature stores, model registries, and so on. There's not a great deal of time spent around the ops side of the coin and how we create and provision these tools effectively. At AltaML, we do a number of different projects for a number of different clients, and this can present some challenges when creating these environments that we need to do the ML work. And that's not a problem just unique to us, but we're also seeing these struggles in industry, especially in mid-sized to larger organizations that have more complicated constraints and controls around their cloud and on-premise infrastructure. And there can be little nuances for every one of these companies, depending on what industry they're playing in. You know, if you're in health, there's a number of compliance issues, as well as other industries have these struggles too. So a number of the requirements that we see is, as I mentioned, there's different certifications and compliances that you may follow as an organization, SOC 2, ISO, NIST. All of these have various constraints around how you need to manage your environment and evidence that you need to gather in order to be compliant in your environment. And if you have multiple ML projects being ran in your organization, there's a real need for visibility around costing and budgeting. And there's a lot of efficiencies that can be lost if you have a number of initiatives going on, and say you have redundant environments created, you have some expensive TPUs, GPUs running in the cloud. You may not be using that effectively, in that there may be a project not running on one and running on another. So there's some room there for some efficiency, and also the ability to securely move your data around in your environment. And this can be a real issue when dealing with PII data, personally identifiable information. If you have customer data, that kind of stuff moving around your environment, in order to be compliant, you need to know who is accessing this, when it's being accessed, and so on. And in some cases, you might have multiple environments that you're dealing with. Say you have some ML environments that you need to create on premise. Maybe you have multiple clouds. You're working with AWS, GCP, Azure, a combination of those, and you want to create ML environments and do ML in these different clouds, in these different locations. And you want to be able to do that consistently. So this creates a real problem for ops teams and IT teams. There are organizations that may not have huge ops teams and IT teams, and they can be overwhelmed with the need to create a lot of this stuff for ML environments. So there can be a constant need for new environments to be created if a lot of projects are going on. And in many cases, the technology that ML engineers are using is pretty cutting edge. A lot of these new things like feature stores and all the stuff being provisioned in the cloud makes IT a bit discomfortable, because they may not have provisioned it in the past, or they may not know it that well. And so IT can be a bit hesitant when creating these environments, and it can take a long time. And rightfully so. It's IT's job to ensure that these environments will conform to the constraints of the organization. And they may have to do their homework before they can create some of these things effectively. So this kind of leads to two outcomes that we found in industry. Either the IT team and the ops teams take a very long time to create environments for ML engineers, or you end up giving administrative access over to the ML teams or elevated access to the ML teams. And then this can create a real auditability nightmare for ops and IT, as you may be provisioning more than you need. You may be provisioning a number of things that aren't used anymore, and it creates a really messy kind of cloud environment when this stuff happens. So therein lies the problem. How do we provide ML engineers with the tooling that they need to do their work while requiring some type of order and ability to see what's going on inside our environments? So the approach that we took here is an idea that we like to call environment blueprints. So the concept is we want to create a system for developing blueprints that allow ML developers to contribute and create these environments. So create a blueprint for the environment they need with the tooling inside that environment that they need. And it'll also allow for security teams, ops, IT teams to take a look at what these environments will look like from a blueprint perspective, check them for compliance, check them for possible efficiencies or misconfigurations. And once we have these, it'll allow us to provision environments in a scalable way. So again, if you have multiple ML projects and you need to just create these quickly for these projects or take these down, these blueprints will act as the way to do that or the path to do that. So this concept is not really new. It's borrowed from engineering. And if anyone's familiar with the DevOps concepts, CI and CD, this is kind of taken and inspired from that idea. When I was a junior engineer, I came from the development side of things. It was very common to remote desktop or access a production system directly. I remember installing, much to the chagrinest of the teams, software directly onto production and installing tools directly onto production. So as engineering matured and the concept of DevOps came around, we started seeing systems that give you some control over deploying your piece of software over and over again. So CI and CD. So it's very similar in this case. I think ML ops is still in its infancy, and ML engineering still hasn't gone through that maturation process where a lot of these systems for reproducibly deploying environments for models and stuff, it's just maturing now. So taking that concept from DevOps, we'll be borrowing that in how we do this. So that's great. How do we create these blueprints? How do we make these blueprints? And there's a number of ways that you can go about creating these. And it really depends on the requirements of your organization. If your organization relies solely on a specific cloud provider, each of these cloud providers do have provisioning languages that you can use to blueprint out environments. So in the Azure space, there's ARM, CloudFormation, and AWS, and then there's scripts within Google's Cloud Deployment Manager that will let you do this. Then if you want to go down a more vendor agnostic route where you're not tied to a specific cloud language, then you may have heard of Terraform. It's a very popular technology for doing some of this provisioning, Ansible and Chef. And you could also create these just with Bash or Python directly. So there's some lessons that we learned when choosing this technology. It's very possible that you can't just pick one of these. It may not be powerful enough to provision all the nuances of your environment, but it's important to keep it to a minimum. The goal of this is to have multiple teams be able to at least review and contribute to these blueprints. So you don't want to create a number of different technologies in there that somebody needs to learn in order to provision these blueprints effectively. So at a high level, what does this look like once we have our blueprints? So these are some of the core components to what a system like this would look like. And I'll go through each of these individually here in the slides to come, but I'll talk at a high level. So the idea is you will need some kind of UI or self-service portal, and this will allow individuals to see and deploy these blueprints. Then the next component is some type of system that will actually run the blueprint. So we call this kind of the provisioner. So the UI will hand over to a provisioner. the provisioner will execute your blueprint. And these blueprints may have to reach out to multiple systems in order to provision what the environment looks like. So I'll give you an example of a blueprint that we like to use. If, say, we're starting a new ML project, we may need to create a GitHub repo as part of this. We may have to create some cloud storage. Maybe it's S3 on AWS or some blob store on Azure if you use that cloud. And then we may have to provision SageMaker or Azure Workspaces, something like this, in order to do that. And then they all need to be tied together from a security point of view, that the users using these environments have access to all the various different systems. So that's the job of the provisioner, and that's what's defined within your blueprint. And then the last component here is for monitoring and deprovisioning. So just keeping inventory of these environments and doing things like I mentioned before with costing. So we'd want to monitor all of these things for costs. Are they still running? What's going on with these environments? And when it comes time to deprovision them, take them down. So I'll talk first here about what this self-service portal is. There's a number of different technologies that you can use to create this self-service portal. There's the ones kind of mentioned here on the right: Ansible Tower, CloudVault, Terraform Cloud, and ENV0. There's a bunch of other ones, and it does depend on what you choose to write your blueprints in. Obviously, Terraform Cloud is more attuned to Terraform, so you may use that if that's the technology you go through. But the purpose for this portal is that system to allow ML engineers to request the environments that they need directly, like a self-service portal. And what we can do is add an authentication and role management around this. So you may have 10, 20 blueprints, but depending on the role of the ML engineer, they may not be able to provision all of them. You may want to control that. There's also a need in some cases for approval. Let's say you have a junior ML engineer that's just joined the team. They need a new environment to do their work. So they would put in their request, but you may not want to provision that right away. You may want to set up a system from which they get approval from, say, their supervisor, or maybe there's approval needed for budget at a PM level or something like that. So these self-service portals can facilitate that. So ensuring that things are provisioned once they are approved or once they go through the proper process. With these blueprints, you can have some simple configuration choices as well. Say you want the ability to give a naming convention for the project. The project will need a name. Maybe the project, there's a couple of different places you could place these ML environments, on-prem, in the cloud, something like that. So these UIs provide a way to fill in these configuration choices before the blueprint is deployed. And it also provides an interface for the administrators to take a look at these blueprints, so we can see a list of them. We may be able to edit them through the UI. Also, you can take a look, though, how many blueprints are active right now, who requested those blueprints, and whether they need to be shut down. So these self-service portals can also include some of those other components that I mentioned. They may also do the provisioning, and they may also do the cost analysis, so they can take a look at the blueprints and see what they're costing you. So we'll talk a little bit about the provisioner here. And this is just the system that runs your blueprint code. And as I mentioned, depending on what you've chosen for a self-service portal, or depending on what system you've chosen there, they may also do the provisioning. In some cases, that is very true. I mentioned Terraform Cloud there. If you use that technology, it will be doing the provisioning for you. But that may not always be the case. You may want to separate that out. And that can depend on some constraints in your environment. If you're on a heavy regulated or a highly secure environment, you may not want your blueprint code ran in the cloud. You may need it ran within your infrastructure on-prem. So there's a number of ways to do this. You can create a VM that does this, or you could borrow from, as I mentioned, CI and CD. So you can borrow from those technologies and use some kind of CI/CD tool to execute the blueprint. So that could be, Jenkins. There's GitHub Actions here, so that can use GitHub to provision these. There's also some systems within Kubernetes. You can create containers that provision these blueprints, and you can use Kubernetes to manage these. And yeah, this is very similar to a build agent in the concept of CI and CD, if anybody is familiar with that. So then monitoring and deprovisioning. So this component is in charge of three main pillars. The first being that monitoring and cost alerting. You may want to be monitoring for runaway costs. In some cases, it doesn't take long for some of this infrastructure, especially if you're using GPUs, TPUs, these kind of things. It doesn't take long before costs start getting out of hand, and you want to catch those as soon as possible. You don't want a giant bill at the end of the month that just completely destroyed the budget of your project. So this component will be monitoring for that. And it'll also ensure that costs can be tied to a specific project, or costs can be tied to a specific budget within the organization. The next piece is compliance monitoring. So if you are an organization that follows SOC 2, ISO, one of these compliance frameworks, you're going to need to gather evidence in order to be in compliance. The auditors really like seeing that stuff when they come and refresh your certifications. So this monitoring and deprovisioning component will act as the system to gather that evidence, to make sure you have a list of who provisioned what and when, these kind of things. And then lastly, this is in charge of deprovisioning. And this might not be as simple as just destroying and cleaning up what it is that you created. In some cases, there can be a lot of artifacts in these ML environments. Say some new data was created, or say some models were created, and you want to shelf the project, or you want to tear down the ML environment. You may not want to destroy everything. It's possible you need to put some things into cold storage. It's possible you need to keep some logs somewhere, or keep some kind of remnants of that environment that was created. So deprovisioning can be almost as complex as the initial blueprint itself, depending on what you need done and how you want to deprovision things. So how would you get started? As an organization, if you're starting at ground zero and you're just doing everything very ad hoc, how can you take this concept and start building it and getting a little bit of order with your ML environments? Kind of broken it down to 4 important steps here. The first step is to establish your base environment requirements. There are a number of different technologies to accomplish this idea of blueprinted environments. You really need to know what your requirements are before you pick one. You don't want to end up picking the newest and shiniest technology and then realizing it can't provision or it can't work the way that you need it to work. So I would start by taking a look at where do these environments need to be? What technologies across the teams, or what technologies are the teams familiar with that will be consuming and using these blueprints? Who should be creating these? Who should be auditing? Those kind of things. So really understand your requirements before you jump into picking the technologies here. Then we create an initial environment template, and you can start with this manually. So just go in and create the ideal ML environment with all of the tools set up and in the way that you like it. You may even want to run a quick mock project, or if you have a small project, run it on that environment and figure out how it performs. Do you need to add more things? Do you need to have systems for dropping data in? Do you have that as part of your blueprint? So do it manually. And after that, once you're happy with that environment, then create the blueprint. So create the script that will create that exact environment that you're looking for. Then you just need a system for running these blueprints. And everybody likes step 4, which is the fancy, nice UIs that give you all the self-service part. But you can start by running these manually to start. Depending on how your teams work, you could maybe have the ML team leads execute these blueprints manually just by triggering them or running them in whatever system. Maybe your IT team does everything through tickets. So if you had these environments, they could be executing and creating these just ad hoc through tickets, but at least it's testing out the blueprint and ensuring that the blueprint can be deployed properly. And then the final step is the the top of the mountain that everybody's looking for, the self-management system that gives you all the fancy budgeting and everything. That would be the final step. You want to have your blueprints created and working well before you start creating these UIs or using these or adding these into these UIs. So I want to talk a little bit about the lessons that we learned while moving over to reproducible environments at AltaML. So adoption is key. Depending on where you start, it's very possible your ML teams are all kind of working in different environments or environments that work for them. Because the ML space is pretty new, there's a ton of different tech that comes out every week that helps ML developers do their job. And it's very possible that you see a lot of different pockets, depending on the size of your teams of technology being used. So adoption is going to be one of the hardest points to get a unified environment together. And that's why it's important to get your requirements and talk to those teams, figure out what you can create for them that they'll enjoy using. And then if you can create that environment in a way that's better than how they're doing it now, that really helps with adoption. So that was a key lesson that we learned. And then consider the requirements before choosing the tools. Don't jump to a tool that looks really good in a video or a demo before considering how that can be done. And then lastly, there will be a bit of a cost upfront in terms of effort here. So to parallel it with DevOps, it's very easy to just deploy apps by directly accessing production. It takes a bit of time to create the systems to have it deploy in a consistent and scalable manner. So there's a bit of cost upfront in creating these blueprints, getting these systems provisioned and building them out, but it will be paid back by both pain on the IT side when they need to audit stuff and they don't know where it is, but also if there's a self-provisioning platform, it becomes a lot easier for ML developers to request resources than just harassing people with tickets or having to get admin access to do it themselves. So you'll see a big payback for this once it is created, but there's an initial bit of effort there to create it. So yeah, that's the idea. That's my initial presentation. Is there any questions that I can answer? Okay, I'm not seeing much in the chat here.
Yeah, thank you for the nice presentation. We enjoyed it, and that was a well articulated presentation. We're going to wait for questions from the audience. I'll still be looking through the chat to see if any questions comes up. Yeah, I just want to ask a question. Maybe can you highlight for the audience and maybe me too the work that you do at AltaML? What's the what does AltaML do? Like, what's the line of work?
Yeah, so AltaML is an applied AI company. We engage a number of different customers in different verticals, different industries. And a lot of times these clients have a lot of data and they have a lot of use cases, but they may not have the internal teams for doing AI and ML. So at AltaML, we engage with these clients, we take a look at their data and their use cases, and we see if there's some potential to apply AI and ML to solve the problems that they're having. And then we take that, and if there's viability there with the use cases, we try to create actual applications. So the applied side, can we create some kind of service or something that we can augment that business with, or is there a product available there within that industry, given that data, that can disrupt kind of disrupt the industry? Use AI and ML to transform it.
Okay, no problem. Thank you so much for that. We have a question from Ri Wang. He said, do you have any tooling suggestions around monitoring and the provisioning?
Yeah, so monitoring and provisioning, we use a tool. We're experimenting with a tool called Cloudbolt, and I don't want to recommend a specific vendor. It seems okay. All of these tools have a bit of trade-off, though. We noticed, like, you can do some of that cost monitoring stuff through I think it's called Cumulus or Nimbus. I can't remember the name now. There are these tools that really help with the cost monitoring stuff. On the provisioning side, depending on your self-service portal, you can add a provisioning blueprint alongside your, or sorry, a deprovisioning blueprint alongside your provisioning blueprint. So if you're using a system, I'm just thinking like a system like Cloudbolt, when you provision a given blueprint, you can add an action for deprovisioning, and that can link to an additional blueprint that does all the deprovisioning stuff. So there's that option there. Looked a bit into stuff like Terraform Cloud and stuff. They do have options for deprovisioning. I'm just not quite an expert in how they do that, but there are some components there for triggering another blueprint. Conceptually, it's best to think of deprovisioning as another blueprint, basically a blueprint that goes beside the blueprint that does provisioning, because there can be some complication when you're deprovisioning, especially for us. We want to back up data and do stuff like that. So it's not as easy as just calling delete commands.
Oh, okay. Thanks so much for that. And then I have another question from Riwang. Says, like your idea about self-service portal, have you come across Backstage? If yes, how does it compare against the tools you listed?
Yeah, actually, Backstage is something that recently came on our radar. I would say from the demos and the screenshots and stuff that we've seen, it looks very promising. We just haven't dived into it or implemented it quite yet. I think some of these tools, though, have a lot of potential. I feel like right now the tooling is good, but a lot of it comes from a space, kind of an older space, when you would provision just virtual machines and stuff like that. So there's a little bit of that remnants left over in a lot of the tooling. But Backstage looks like it has some potential and can do things a little bit better, but I don't have a ton of experience there other than that.
Okay, thank you. And we have another one from Emily Wheeler. So where do you find the data scientists fit best in the organization to facilitate MLOps? Is in IT or in the business?
This is a great question. I don't know if the industry has even figured this out. Yeah, it's really tricky. Like, we find you can get some data scientists that are not interested in MLOps, and they're more interested in, say, the math. They're much more a purist data scientist. Those are not the best fit on the MLOps side. But if you maybe take somebody from traditional engineering or DevOps, if you take somebody from DevOps, they might not have as much exposure to what ML does. So then that can be very difficult when they're doing some of this MLOps work. So I would say, right now the best success seems to be coming from ML engineers or people with experience, not just with doing data science, but a little bit of that applied side. So if they're an engineer with some data science experience and they have interest in going into more ops like stuff in DevOps, yeah, unfortunately they're difficult to find, those people. The stars need to align correctly. So if you can find people like that, they're ideal, but we may not be lying around. So if that answers your question.
I think he answered Emily's question. Yeah, okay. I think we just have only 1 minute to go. Will you share your email so that they can reach you if possible? Is that okay?
Yeah, for sure. Here, I'll add it into the chat here. If you want to get a hold of me, I've posted up, reach out to me on LinkedIn. I'd love to talk about this stuff. I'm very passionate about this, so I'd love to have a virtual coffee with anyone that wants to know more about this. And I have my GitHub listed here as well. So thank you so much for your time. Really appreciate it, and hope to hear from some of you.
Thank you so much, Mike. Thank you for making out your time. Okay, thanks so much. So if you want to learn more about AltaML, you can visit visit our booth, one of the companies that's sponsoring this event. So you can go there and see more about AltaML. So thank you all for coming for this talk. We'll now close this section.